Welcome to homework.
Problem 15.203, we have these two colors there connected by the rod A B of length 25 inches. And we know that color B slides down with constant speed of 20 inches per second, and we need to calculate the velocity of color A as B passes, specifically through point D. So this problem actually is easier to solve without any reference to the angular velocity of the rod A and B. The plan is to construct expressions for the positions of color A and color B. And given that the vector difference will always be constant, that will be just the length of rod A and B, always 25 inches. Given this fact, we can construct an expression, the position of color A with respect to time. And then if we take the derivative of this expression, we can immediately calculate its velocity. And if we evaluate this expression for a specific time, we get the velocity for the for color A as B passes through point D. Let's do this more analytically. So let's focus on point B. Color B. Color B must be always along the line CE, which has a specific constant slope. Therefore, its velocity must be of this form. No Z component there. Hope this is clear from the drawing. And the relation between the two components of the velocity of color B is of this form. This tan theta is just the slope of a rod EC. And someone from the drawing can see immediately what is the value of the slope. This is just 9 inches over 12 inches, again from the drawing. And of course, negative. And now, given that VB is constant over time, always 20 inches per second, someone can, if someone does the calculations, can find the specific value for the x component of velocity, thus calculating the whole expression, which is 16 I hat minus 12 j hat inches per second. Okay, so given the velocity, given the expression of the velocity of color B, which is constant over time, someone can construct an expression for the vector position of color B as a function of time. Okay, this is constant. So immediately RB as a function of time can be written as an arbitrary point taken for time equals 0 times time variable and the velocity vector. Okay, and if we set that RB net equals the position of color B as it passes from C, point C, then I hope it is clear that this is obviously a very convenient choice. And from the drawing, I hope it is clear that we get an expression like this. Always in inches. Okay, if we have this information now for RB as a function of time, then we can go back, as we said before. We know that this expression, this norm, is always constant, equal to 25 inches. And if someone, replaces the values, this is still unknown. This is just arbitrary for the moment. So replacing this expression for RB position, we get I will use only the y component of the position vector because there can be any other component for the position of core A. The position is always of this form. Again, this is from the drawing. And next, someone can solve for RA, RAY as a function of time, whatever. And that will give and then we can calculate the expression for the velocity of color A by taking the derivative of this expression. Which is, of course, again, along the y-axis. And by doing the calculations, someone gets minus 12. Yeah. The science flip. Okay. Again, this is from doing the calculations more carefully. T squared. And now, the question was specifically to evaluate, to calculate the velocity of color A as color B passes from point D. Point D from the drawing is at this specific position, 12 hat plus 20 k hat inches. And if we compare this position with that whole expression, someone can see that we can get that position if we evaluate the above expression for time equals 3/4 seconds. And if we replace that time inside here we get two values, of course, because we kept two signs there. Time equals 0.75 seconds over. And this is rejected because it is positive, and this is the one that we keep. This is the final answer for this problem.